All right, so I want to go over, I'm going to just go through these 5 or 6 questions, and then if you have further questions, we can discuss those, okay? One thing to pay attention to, I guess, when I know this is section 1.3, if you look at these numbers here, okay, the first number is the chapter, the second number is the section, the third number is the number in the actual physical textbook that this question pairs with, okay? Now, you might thinking, well, you put 1.3, but that says 1.4, right? So you're saying I gave you an assignment out of a text that we haven't talked about, or a section we haven't talked about. See the asterisk beside that one? The asterisk means this comes from another textbook. And in that textbook, our section 1.3 is actually section 1.4. Does that make sense? Every assignment, I can pull 20 questions from different textbooks, and I do that occasionally. The asterisk tells you what section that was in that textbook. I will never give you a question without notice that it's something that we haven't covered yet. Okay, I might give you a question, say, hey, on tonight's homework, question 20, we haven't seen it yet, but I want to see what you already know. Try 20, see what comes of it. Okay, and then when I grade those, I will be cognizant that I put that in there, and I'll grade it fairly to you. Okay, so those are just things to keep in mind as we move on. But this one says on a number line, suppose point E has coordinates -2 and EG equals 12. So what are the possible coordinates of point G? So this wants 2 answers. Think about this here real quick. If I have our number line here, let me just put in a number line. Let's go y equals 0. And I put the point. So that point right there would be 0, right? Does that make sense? Okay. If I put in -2, they are asking if you had a segment that was a length of, what did it say, 12? A length of 12. So this is E. I'm going to rename this. This is the E point they gave me. And I have a segment with a given length of 12 units. And it has to be on my number line. So this is 12 units long. Does that make sense? Okay. It could be down here. So now remember, this point be easier if I can put some numbers on here. This location was our 0. This here is -2. I know it's naming this B, but that would be the G in our question. If that's 12 units long, what would the coordinate right there be? It should be 10, because I'm starting at -2. Does that make sense? So if I walk 12, if I start at -2 and I walk 12 units to the right, I should be standing at the coordinate 10, right? So G could have a coordinate of 10, and a lot of people, most people will get that. The one that they miss is that it does not, and this is the thing about geometry, it does not specify the direction that you had to walk from E to G. Does that make sense? So if I'm at -2 and I walk 12 units this way, what coordinate will that put me at? -14. Okay? So that's what they're looking for here. Pay attention to directions. I know last year in Math Excel, a lot of times it was just, type in the one answer. If there's multiple answers in the parentheses in blue there, it says type integers or decimals, use a comma to separate answers as needed. We need to make sure we do those things. So I'd be looking at 10, comma, -14. Is that okay? Or you put -14, comma, 10 and it'll work either way. One thing I want you to be aware of, whether you take the end of course exams this year or you take them in upcoming years, I know the state legislature is still deciding whether students are going to take those this year because of everything that's going on. I do a lot of my homework and tests and quizzes in Math Excel for the mere fact that when you take the end of course exam, you do that on a computer. okay? And if you typed in 10, comma, negative 14, you get the right answer. But if you type in 10 decimal negative 14, it's going to say it's wrong, correct? Okay? Comma and decimal are right next to each other on the keyboard, right? Okay? In my class, if you do that, if you make an error like that, typo like that, and it's legit typo, and I can't see any mathematical error that you would have maybe gotten that amount without the typo, I will go back and give you credit. Does that make sense? Okay? But on the end of course exam, when that's getting sent to the state, you can't argue to the state. They're going to say you are wrong. You're a bad geometry student because you hit period instead of comma. Does that make sense? It's not fair. I mean, you obviously you did things right, but with that typo, it says you're wrong. It says you're a bad geometry student where you're not. But there's no way that you can debate that and argue that. All right. So I want you to get practice at that detail and being very cautious when you insert answers into this stuff. Okay? I've had students in my 12 years, 13 years of teaching, we've done the end of course exams like maybe 5 or 6 years. And I've had maybe 4 people not pass it, and they've not passed it by, like, they need like a 700 and they got like a 698 or a 697. And I would argue that if we went back through their entire test, they could probably get those points based off of some typo somewhere. So you just want to be cautious of that. Questions on that one? Does that make sense now? In geometry, we always want to think about all possibilities, all types of possibilities that could exist. I want to say this one's a hard one, at least in my opinion. I want to say that one to the end. Let's see, 1.3, number 20. So this is question 7 in your homework. This is like the last one we did yesterday in class. Okay, it says use the figure to the right to find the value of PT. Okay. I look at some of your answers. A lot of people answer this with X. They got the right X value, which is needed to find PT, but they just type in X. Does that make sense? So make sure that we're paying attention to those types of things. What do I know? So I look at this, and a lot of people, just because of the questions that came before it, are going to type or write something like PT plus TQ equals PQ. Would you guys agree that that is a true statement? Okay. So when they start doing this, they say, okay, PT is 4x plus 7. TQ is 7x minus 5. PQ, I don't have anything from the description to put for PQ, right? And then some people might just write, 11x plus 2, because that's what the left-hand side combines to. But when you do that, you've created what we call a trivial equation, where the left-hand side is identical to the right-hand side, and it's not going to generate an x value for you. Okay, it's not wrong, but it's not going to give you an answer. This happens a lot with this type of question, because we just see, I think when we open things up, and I'm guilty of this a lot as well. Like I just see, this right there, I see that right there. I'm doing segment addition, and I did not read any of that in blue. Does that make sense? But if I read that in blue, is there critical information there? T is the midpoint of PQ, right? Okay, so T is the midpoint of PQ. So what that tells me is a different equation. That distance PT and that distance TQ, they are the same. They are equal. Okay. Another thing, we didn't talk about this yesterday in class, but if I want to show two segments and my picture are congruent, I put those little hash marks in. I got those little red hash marks up there right now. That is imagery to tell me that two segments are congruent. Okay. So then I just set up my equation. 4x plus 7 equals 7x minus 5. Move the 4x over. I'll move my 5 over, divide by 3, I get x to be 4, right? Like I said, I get a lot of answers right there to be 4. Is that what PT is? PT is not 4. PT is 4 times 4, which is 16, plus 7 then. PT is 23. So biggest errors is it's not necessarily mathematical or geometric errors that we make. It's more procedural stuff. Didn't read the directions. Didn't read what they're asking for. So just be on the lookout for that stuff. All right, so this one says, let me cut this out and put it on a different screen. Easier to deal with. All right, says the numbers labeled on the map of Florida are mile markers. Assume the Route 10 between Quincy and Jackson is straight, okay? You travel down 75. You see those little signs on the right-hand side that have the mile markers on, right? Okay? That is the number line, okay? That is the ruler postulate because it allows you, if I see that I'm on mile marker 50 and then I fall asleep and I wake up and I see that I'm on mile marker 74, I know I've traveled 24 miles while I was asleep. Does that make sense? Okay. Those are kind of things there's going to be a lot of questions in this class that we can relate to actual real life experiences that we have. And if we do, we can talk about those. But we're talking about Quincy to Jacksonville, right? Okay. So Quincy's up here. Okay. And Quincy is saying that they are located. So I'm just going to just transform this to a straight number line. Quincy, call it point Q, is located at 181. That's the mile marker. And we're going to go to Jacksonville, which is down here. So I'll make this J for Jacksonville, and that's 357. Okay? And it wants to know the distance that you're going to travel between those two things. Okay? So how do I find that distance? Joel? All right, so I'm going to go 357 minus 181. Okay. 357 minus 181. We know what that is? 176. Thank you. Okay. So when we're choosing our options here, let's go back and some of these questions are like multiple steps. They're tiered questions. So we'll jump back and forth so we can actually answer it. So how can you use mile markers to find the distance between points? So it's asking you how can we use mile markers essentially to do the ruler postulate. So treat the mile markers as coordinates and get the absolute value of the difference. Option A, good job. So if I'll check that and it gives me then another part, right? Continue. How do average speed, distance, and time all relate to each other? Okay? So this is something that you have to go back to maybe 7th grade math, 8th grade math, maybe did some of them in algebra. But how are these things related to each other? Joel? Okay. So what I'm going to do is I'm going to do this to make it more obvious for everybody. Like you guys know, distance equals rate times time, correct? Okay. So that is an equation or a formula that we can then solve for R or solve for T. So there's three versions of this equation or this formula that we can deal with. So we're going to say R is equal to distance divided by time. So rate equals how far I've traveled divided by the time that it took. And I could say time is the distance divided by the rate. Okay? So we just have to go through A, B, and C and see which one of those talks about one of those three options. Okay? So you said which one? Okay, so distance divided by average speed, and that should give you time, right? Okay, so when we say rate in this situation is our average speed, right? That's what we're talking about. So option A states that. And now I just asked this, well, how long is it going to take? It says it will take blank hours to get from Quincy to McElhaney. How do you say that? So now what I got to do is I got to do a different scenario. It would be nice if it said Jacksonville, because I've already figured out what that distance was, right? So now I got to go Quincy to, so 181 minus 335. Okay, so what's that, 19? So that's around that 20, 55, 54. Is that 154? Okay, so that's my distance. I'm going to divide that by, it tells me I was traveling at 52 miles per hour, right? So divide that by 52. Okay, and then, what to say, round that to 2 decimal places. So once you do that, you type that in. Does that make sense? Okay. Again, this question, I think it's I think it almost tries to trick us because, oh, well, I guess, yeah, okay. So early on, like I said, I think it tries to trick us because it talks about going from Quincy to Jacksonville, right? And as we go through and answer the questions initially, we're talking about Quincy to Jacksonville. My fault. I didn't read this part here, I guess. We did everything right. So I found initially Quincy to Jacksonville. We didn't need to do that. This was the overall question, right? So there it does talk about Quincy in whatever the other city is, McElhaney, whatever. And those are the data points that you're going to use. Does that make sense? So I apologize for that being maybe confusing the way I expressed that, but anybody confused? Anybody struggling with that? We're all right? Okay. Let's try. Okay, so that's the same question that we did previously. So skip that one. Okay. Just real quick, imagery-wise, if I look at these segments up here, okay, the segments that have one, like purple or whatever color that is, marking in them, those segments are congruent. That's what that notation means. The segments that have 2 markings in them, those segments are congruent. Okay? Anything that has 1 marking is only going to be congruent to anything else that has only 1 marking. Same thing for 2, same thing for 3, and so forth. So from this, we should get the idea that segment A to D, which is this one here with the 2 marks in it, should be congruent to DC, which also has 2 marks in it. Okay? ED, segment with 1 mark, is also congruent to DB. Okay? What that allows us to say, and I'll explain eventually this notation to us in chapter 2, we have an arrow, a double way arrow here. Basically it means if AD and DC are congruent, it automatically tells me that their distances are equal. Same thing for ED and DB. Their distances are equal. What those double arrows mean, it means the phrase if and only if, and we'll talk about what that means later on. I can start with the left-hand statements of congruence, and it leads me to the equality statements, or I can start with the equality statements and it leads me to the congruent statement. So it's essentially a mathematical sentence that you can read left to right or right to left, and still have truths. So, of the information they give me here, can we take, they say AD is 12, so I'm just going to replace over here in these arguments that AD is 12. They don't give me DC or anything like that, right? They don't give me ED. They do give me AC. So, okay, so here's an argument that we have to make. Let's look at, because they don't give me that specific value, or that one, correct? So you might be thinking, well, I'm stuck on this. I don't know what to do. What do you know about AD compared to DC? They're the same, right? So if they told me that AD is 12, what's DC? DC is 12, right? That's the idea of congruence and equality. So AC then, if AD is 12 and DC is 12, what's AC? 24, right? Did we just now establish a link saying AC is 3y minus 33 is that algebraic expression, but it is also 24, is that? Does that make sense to everybody? Okay. So what I'm going to do is create the equation that 3y minus 33, which is AC, is equal to 24, which is another way of identifying AC. Okay, so if you have multiple ways of identifying the exact same object in different algebraic formats, that's going to allow you to create an equation. So there I'm going to add 33 to both sides and then divide both sides by 3. Is that okay? I think you guys all graduated Algebra 1, okay? So, like, when you get down to equations like this, I'm going to take the liberty that you guys can solve those. If I ever do that and it's an equation that maybe you struggle with or you're confused about, let me know. It just saves time in going over homework, saves time going over things in class. Questions on that? All right, let's open up I think we got one more. Yeah, it was this 48. All right, so I'm gonna cut this one out and put it in a different program as well. Now, I heard some of you say that this assignment was hard initially. Going over some of these, is it clearing some of that stuff up? Okay. Those are also things that I want you guys to kind of communicate to me. If an assignment was hard and then we start going over homework questions or talking about the content again and it still remains confusing or hard, and we don't alleviate any of those problems, let me know that stuff so we can work towards alleviating those. Otherwise, I think we're spinning our wheels, wasting our time. Okay, so make sure that you guys communicate that. Okay, so this question, it is the segment addition postulate, but it involves a little bit of subtraction. Okay, and that's fine. I can walk 10 feet, walk back 2 feet, and then walk forward 6 feet, and ask you how far total did I walk forward. Okay, so I walked 10, back 2, so forward I've only walked 8, right? And then 6 more forward would be 14. So that's kind of what's going on here with this situation. We've got some distances that we're going to have to remove. Okay. It says, what algebraic expression represents G to K? So G to K. So we're trying to figure out if you stood right here at G and you walked to K, how far would you walk? Okay. The way I'm going to do this is I'm going to say, okay, if I started at G and I started walking, The first thing I see, just because of this mark right here and this arrow, is that I'm going to at least walk to J, right? Does that make sense? Okay. So if I start at G, I'm going to at least walk to J. So I know that G to K is going to at least involve a 2x plus 5 quantity, right? Like it's going to be more than 2x plus 5. So I'm at least going to write down the 2x plus 5. Okay? Now, when I start walking again, so I pause here at J, I stop, catch my breath, whatever, and now I'm going to continue walking to K. Well, if I'm going to continue walking to K, I'm only going to walk kind of that portion of that top line, right? Does that make sense, everybody? That whole top segment is represented as 5x minus 4. Well, if I walk that whole thing, it'd be 5x minus 4. But if I walk part of it, isn't that part going to be less than 5x minus 4? Do we know how much less? It's going to be x less. So this x right here, so that distance right there, we can see being that distance, right? So that right there is going to be 4x minus 4. Is that okay with everybody? So when I walk from G to K, we walk the green, but then we walk this 4x minus 4. So those are cumulative. We're going to add those together. Now, if you type that in, I think it's probably going to give you an error and say you've got the right amount, you just haven't simplified it. You got the right expression, but not simplified. So we're at 6x plus 1 would be what we're looking at there for G to K. Is that all right, everyone? So then when they ask us then, well, if GK is 43, go through and find these other measurements. So I'm going to go 43 is my GK. I'll substitute that. 6x plus 1. So I get 42 is equal to 6x divided by 6, and x should be 7, correct? If x is 7, and they ask us to go through and find then GH and JK, and knowing that if I look at the information that's up there, GH and JK are not any of these three expressions that they provide. That's not GH, that's not GH, that's not GH, and they're not JK either. So we're going to have to do a little bit of algebra in a moment as well. But I'm just going to go ahead and see what this is. H to K, so 7 times 5 is 35, minus 4, 31. Okay, 2 times 7 is 14, plus 5, 19. And this x is 7, right? Does that make sense, everyone? Would you guys agree if I watch GH, bless you, if I walk GH, I'm going to walk less than 19, but don't I walk 7 less than 19? And see how that x overlaps that segment? Does that make sense? So 7 less than 19 would be 12, correct? And if I'm walking H, not H, don't know my alphabet, J to K, I'm walking less than 31 units, and I'm walking 7 less than 31 units, so that should be 24. Does that kind of make sense on how to do that problem? You've got overlap, okay? And that overlap, we have to kind of remove. I get a lot of people to do this type of thing. They'll say G to K is 2x plus 5, and they'll add to that the 5x minus 4. They'll add to that. They'll add those two things together, okay? But what happens is that when we do that, we add that distance x in there twice, right? That distance x was in the GJ distance, and that x was in the HK distance. If I want to do it that way, that's fine. You just have to remove then an x, because you've counted it twice. We only want to count it once. And now combining that stuff, even though that looks different initially than that, If I start combining like terms, it still dwindles down to 6x plus 1. I was anticipating that being a difficult question. Okay, that's a question I put on every year that people struggle with, but it's that extra step. Okay, were we good at the other segment addition questions? Okay, because I think it's important not only to make sure everybody's good at those, but then we challenge everybody. Does that make sense? Okay, so homework you're gonna find out initially. They should start off with maybe some vocabulary, maybe some elementary type questions for that content, that section, and then they slowly build to more difficult. And my hope is that those more difficult ones, those middle of the road questions, that we're all able to master. Okay, and that tells me that we're all proficient. But then I'm also going to put some questions in there that extend our thoughts and push and challenge everybody. Yes. Okay, so you've got is it okay if I keep using these numbers or? Okay. So we got down to x being 7. That was you're fine with that, right? 7.5. Yeah, that's fine. Yeah. So when we get down to that value, I can go in and now know what G to J was just by plugging in to that expression, right? So when I do that with my numbers, now yours are going to be different, but when I do that, I get 19 there. Okay. When I plug into this one, H to J, that gives me 7. And when I plug in up here, it gives me 31. Now, if they want, so basically what they're asking for then is what is that length right there, and what is that length right there, correct? They want those two colored distances. But we don't have, right now, based on the image that they gave us, we don't have specific formulas for those or expressions for those. So we can do it one of two ways. We can actually create what is the expression, or we can think about it through just the numerical values right now that are existing. If you were to start right here and walk from G to H, it's going to put you right there, right? So you're going to walk ultimately that yellow amount, correct? Which should be less than 19. But if I kept walking, so if I stopped there where that bar is and then kept walking that distance right there, how big is that distance right there? Yeah, so I'll make it green. So that green distance is that 7 right there, right? So basically what it's telling me is I should have stopped 7 units short of walking all 19, right? So 7 units short of 19 should be 12, if I subtract this. Does that make sense? And it's not working out? But I'll come work with you in a minute, but does the concept make sense on how to do it? Okay, so let me come look at yours real quick. If we look at this situation, would you guys argue that, and I'm just going to move just so we can see things a little bit better. I'm going to put T right there. That is one thing also, we haven't talked about this yet. When we are dealing with pictures that are drawn by me, by a neighbor, by an author in the textbook, picture size means nothing, okay? So if I look at the original picture inside Math Excel, would you guys agree that it looks like distance R to S is the same as S to T? Okay. Here's the thing. If I was to actually take my, let's take a ruler up there or a tape measure or something that's much more precise than those to measure that, I might get RS to be 36 inches, and ST be 36 and 1/32. Those would be different, right? Okay. Your naked eye cannot tell the difference between like a 1/32 on one segment compared to a 1/32 on another segment, especially maybe at the distance that we are from the board. Okay. So you never, looks can be deceiving. Looks can be deceiving. You're going to hear me say that phrase all the time. We don't want to go off of what it looks like. We want to go off of the known facts that we have. And the known facts that we have in this particular situation are that R, S, and T through the picture are collinear, and S is between R and T. That's all we know. So if we think about what that means, that sets up our segment addition postulate where we can say RS plus ST, R to S plus S to T should give me then R to T. I like to set that generic formula up because now, well, RS is right there. I can replace that with what it's equal to of 6y plus 5. ST is right here, which is that one, and I can replace that with plus and 5y plus 9. And then we got our RT, which is 15y minus 10. Look at my like terms. So those are like terms. Those are like terms. So I'm going to have 11y's plus 14 equals 15y's minus 10. When I get down to equations like this, guys, when I have constants on both sides and variable terms on both sides, I'll move that over, and I'm going to also move that to the other side at the same time. Is that okay with everybody? So it just saves me a step. I can write this as 24 now is equal to 4y, and then divide both sides by y, or I guess 4, and it'll leave me with y equals 6. Does that help? Okay. Number one, if I were to go through like the last 12 years of teaching and just categorize the errors that people make in this class on homework, on tests, and quizzes, the number one error is that they make an assumption about a picture, creating some relationship then that is incorrect. Okay? You never want to make assumptions about pictures unless there's like a vocabulary word that's attached to it that we know for certain allows me to make that assumption. And we'll talk about some of those things. There's like 3 or 4 things that we can assume from a picture throughout the entire year, and then there's like 1,000 things that we have to be shown or told. Okay. People like to read into stuff. They like to think extra about a scenario. Okay. In geometry and mathematics in general, you can only deal with the information that you are provided. Don't read into anything extra. Don't interpret anything extra other than what you're told or what you have in front of you. Is that cool? All right, we'll stop there. The homework, like I said, the first section is due, tonight? 1.2, or I guess 1.2 is due tonight. 1.3 will be due tomorrow night. So again, tomorrow in class, if there's something at 1.3 you kept going through tonight, still didn't make sense, we can go over it again. We talk about it. If it's something new, we talk about it. But there's nothing new on top of today. Yes?